This is the new sanding robot, Sandtronix version 5. I thought I'd go over some of the design choices as it's now substantially done. Substantially done meaning there's a lot more stuff to do, but the main features are all here. Let's start with the frame. These pipes are 21 inches long and they glide on these 16 bearings, 8 on each side. The sanding robot can be adjusted from about 12.5-inch opening between the roller skate wheels all the way down to about 4.5 inches. These stainless steel rods up here are 1/2 inch in diameter. Not only do they hold the sanding robot together at the top, but they also allow the sanding carriage to slide back and forth on this lead screw. If the sanding robot is too close, the lead screw goes through that hole right there. This is the heavier side of the sanding robot. The drive system consists of these two hollow tubes connected to the stepper motor with these chains and sprockets. Originally, I just wanted one drive roller which could swing over the top of the robot and start driving on the other side if the robot got to the end of the beam. But look how much easier this is. As a feature, these journal bearings have a lot of rotation built into them. So that means I have to add this thing on the other side of the robot in order to push down on the roller. As you can see, that changes position based on how wide the robot is opened up. The cord for the sander and pretty soon the vacuum come through this side of the robot, and we'll have to loop back around to go to the relay box, which will control the sander. This stepper motor controls the lateral movement of the sander. One of the best features of this robot is that the sander is on a type of universal joint, so it can swing around in all 360 degrees of freedom. So it doesn't matter if the robot is crooked or tilted on the beam, the sander will always have even pressure. These are the things I still have to add to the Sandtronix version 5. This is the relay box, which I wired up yesterday. It has 4 relays, which are attached to these normally open magnetic solenoid relays. And those are wired up. The ground and neutrals are all connected to the neutral side of a power cord. And the hot side are all connected to the relays, so it's switching the hot side. I quickly realized that I only need one outlet that can control via the relays. And I need at least one in order to power the other electronics on the robot, mainly the drivers for the stepper motors. So I ended up wiring one of the outlets to be normally open, meaning right now this is connected naturally, and you have to energize the relay in order to disconnect it. And I'm just always going to leave that not energized because I'm always going to need power for the power brick, which will power the computer. The main computer will be an Arduino Mega for now. There will have to be a secondary computer, probably an Arduino Uno, to power the drive motor for the sanding robot because Arduinos are not good at powering more than one stepper motor per unit. I haven't been able to power more than one stepper motor per Arduino board, so therefore I have 2 stepper motors and I will need 2 Arduino boards. I was trying to get the Big Tree Tech 3D printer motherboard to work, but for some reason I can't get the code to upload to the board, even though it compiles just fine. I'll have to take a few more weeks to figure that out. There's another advantage of having 2 Arduino boards, mainly the sensors, which I'll be using to detect when the robot hits the edge of the beam. So I machined these to perfectly accept the laser distance sensors that I bought, which will go right here. Now, when it reaches the end of the beam, the particles will be sent out from the sensor and reflect back and determine that there's a drop-off of the edge. And then the Arduino Mega will be connected to the sensors and know that information. And once it sees that, it will send a 5-volt signal to the interrupt pin of the Arduino Uno, which is powering the drive stepper motor. That will cause it to drive just a few more steps until it reaches the center of the robot, which would be underneath the sander. So as the sander is hanging off the edge of the beam, this roller will no longer have friction on the beam, and it will essentially be leaning. But then the motor will stop and reverse the other direction and start driving backward. And then the distance sensor that's on this side will be activated to determine when it reaches the edge of the beam on the other side. Right now, this sanding robot weighs about 29 pounds without all the electronics added on. That's more than I thought it would be, but I figured that I can do some weight reduction in here by cutting out sections of plywood. It's as if the robot is pushing down on the sander in the exact center, no matter what the weight distribution is on the robot. I'm going to try my best to balance it by having the relay box and electronics on this side of the robot, because this drive setup is very heavy. Another design I want to do in a future model is to make these rollers do the driving as well as holding the sanding robot together. When you get the sanding robot to the correct width and you want to clamp it onto the beam, all you have to do is tighten these knobs out here. You could really get away with just tightening one. So that's all about the sanding robot so far. It took a couple of weeks to build, and I figured I'd give an update video on the features I decide to include versus not include. And next week I should have another update on adding all the electronics to make it actually work and sand beams. That is all.